Hello?
Yes, ma'am.
Yes. So, um, so this is the formula for regular falsi. You all know that. Yes, is it correct? Is the formula correct? This is what you all have done. You all have used. Okay. So we'll just code this now. So what you have to do is you have to just remember, you have to just go for save as. Okay, let me save this as. This was a bisection code. I'm just saving it as R or false position method, FP. Just saving it as false position method. So this was a bisection code which I had. I deleted what was there in for loop because we have to write this. And also I changed this name as, instead of bisection, I have written false position method. That's all. And all these are the same. Now here, you remember I told you to use if else. Okay. So you have another way to do it. Instead of break, you just use abort. That will also get you out of the program. Okay. Abort command will also get you out of the program. So then you can avoid using if else. Okay. So if it is a wrong interval, you print wrong interval and you come out of the program. So you would have used exit in C program, exit of 0 in C program. So here you can use abort, okay, instead of exit. So exit actually brings you out of the program in C language. Also in other languages. Here in Scilab, you can use abort to come out of the program. When it is wrong interval, you don't want the program to work at all. Okay, so that's all. The logic is over there when it is a wrong interval. So you can use abort. Okay, so that is, you can replace now. You have learned something new, abort. Okay, now nothing else will change. Of course, this is the name we gave because it was a bisection. We were writing the code for bisection. Now we want to write it for false position. So we write it as false position. Okay, so you can write, you can give any name. Huh? I can also give FP, no problem. Or you say false P, that is also fine, whatever. Or you can give regular falsy, whatever you are comfortable with. You can give regular falsy, whatever you want, you can give. Okay, the name as. Or also I can stop with RF, no problem. Okay, so this is also fine. This is just the thing that you have to take care is it should follow the rules of the variable name. That is all. Okay. Now, what is the change you have to make over here? Because the formula has changed, but the logic behind forming the loop as forming the, finding the root has not changed. What is the logic? The root lies between a negative and a positive value, positive f of x value. So the x, whatever x you have used to find f of x, so the root lies between that x value. Okay, so how will you know that it is between these two numbers? You will find f of x, and if you have a consecutive negative and positive value, then you stop there and you declare that the root lies between the x which you have used to find f of x. Okay, so that logic remains the same. Then after that, the new root, how will you find? For that, you will apply this formula. Okay, so for the new root, you will apply this formula. So let me just paste this there so that you will connect yourself. I'm just putting this as a comment over here. So hope you all can see my screen so that this is there. So now we'll code it exactly how we see over here. Of course, you will help me in coding. So the formula is this. Okay, so the formula in the sense for us it will be, now when we, this is the actual formula, but when we write it, it would be f of b. For us, b is xu, okay, and then into a. A is xl for us. A is xl for us minus f of xl into xu. Okay, so this is your numerator and denominator will be f of xu minus f of xl. So instead of a and b, this is a formula we study, but when in the code we have used xl and xu. Okay, so this is what we have to write. Now here again, this f of xu we have not declared. We will write it, we have written it as fxu, fxl. So again, I change it. See, I'm just teaching you how to put it in terms of our code. So it will be fxu. We are not going to call a function like this into xl. The first term is done. Then we have fxl into xu. So the numerator is done. The denominator fxu minus fxl. Okay, so this will be our formula. The final formula will be this. Did you all understand, students? Hello? Did you all understand why I replace f of b with fxu? Hello?
Yes, ma'am.
Others? Actual formula converted in terms of the program. Okay, this is converted as per the variables used. Okay, so this is converted as per the variables used. Let me reduce this. Let me increase this so that you will see. So this is what we are going to apply. Yes, others in the meeting, do you all understand what's happening here? Yes, students?
Yes, ma'am. Yes, ma'am.
Others. Shall I proceed? Are you all listening to the lecture? All those are there or sleeping?
Yes, ma'am.
Okay, so now we have to write this formula here. Okay, I'll just copy paste it here. So your your new root is going to be this. Control C, Control V. Okay, so this is going to be your new root. So exactly how your formula is, exactly we have written, but in our program, instead of f of b, we have used f of fxu. And instead of f of a, we have used, yes.
Ma'am, the formula has more closing bracket than the opening bracket.
Huh?
More closing bracket.
Closing bracket. Huh? Yes. The numerator, na? This is not necessary because that will only be done. Okay, this is not necessary. This is it. This is enough because first the multiplication will be done and then the subtraction will be done. So just for the numerator, you need a bracket. That's all. Okay, so when we are writing it like this, we write it in this manner to say that it is a numerator. Here I have used a bracket for the function also. So that is why this bracket is seen. Okay. So hope it's clear, students. There is no need of this bracket. Fine. So you have the formula here, x nu fxu into xl minus fx. See, if by mistake you are putting a bracket over here also, It will not be wrong. Okay, so then you have to put a bracket, one more bracket here for numerator. If you're putting a bracket for this term, then you have to put another bracket for the numerator. So, but this is not necessary because first multiplication will be done and then the subtraction will be done as per the BODMAS rule. Okay, so there is no need of that bracket. So you have found the new root x new, so that is done. Then after that, now we have to, this fxu and fxl will change now as per the new root. Okay, so hope you all remember how the fxl and fxu changes. Exactly like that we have to code now. Okay, those who are not remembering, I'll just write it over here so that you will remember. Okay, so suppose this is x is equal to 2 and this is f of x. This is going to be negative. And this is x is equal to 3 f of x as per the equation you have. Okay, so f of x will be positive. You find the new root and suppose f of x is equal to is negative, then the root doesn't lie here, it is here. Okay, so you have a positive and a negative over here. Now you find f of x here, and if this is positive, then this is not there, the root lies between here, negative and positive. Okay, so hope you all remember this, everyone. Yes or no, students? Do you remember this? Everybody? So
Yes,
this is what you have to apply now. So first you will find fx new, you will find evaluate expression, and you will find. Now how will you set the new? So this is your fx new. This is your fx new. So now we have to, if this is negative, if it is the value that is calculated is negative, then what is changing? What is actually changing? Your xl is changing. This is xl and this is xu. Okay, this is xu. Your xl is equal to x new. Okay, and also your fxl is what? Fxl is what now? Your xl is also changing to x new. Is your fxl changing? Because in this program, in regular falsi, we need the f of xl also. F of xu also we need in the formula. But in the case of bisection, we only needed xl and xu in the formula. But here, we need fxl and fxu also in the formula. Okay, so that is what we have written here. We need fxu and fxl also. So when we calculate the new root, this fxu or fxl is changing, is it not? As you're seeing here. Okay, so here you will have something new over here, but this is here, it will be the same. There is no change. But suppose you have a positive value here, then again xu will change and fxu will change. Okay, so at this place fxl and fxu will change. And if fxu is negative, then xl and fxl will change. So what is fxl, students? What will be fxl here and what will be fxu here? xl will be x new only. What will be fxu and fxl here as per the condition? Hello? Are you not understanding? You're not understanding? I'll teach again. I want you to understand. Huh? Yeah, I'll teach again. No problem. Your formula is different for regular falsi. Nothing, the concept is not different. Okay, the concept is not changing. Only the formula is changing. So this is your x new, your new root. Okay, and you also have to find fx new. Okay, you are finding fx new. Now, why you are finding fx new? As per the formula, no, I'll show this only. As per the formula, in the formula, fxu and fxl is also coming. F of a and f of b is also coming. So every time, either the fxu or the fxl will change. See here, let us go here. Now it is x new you have found out. Let us just assume fx new you have found out. Also, you will find fx new. Now, fx new you found it to be negative. So this is gone. So the root lies between this and this. So xu is not changing. fxu is also not changing. But here xl will change and fxl will also change. Yes or no, students? Are you understanding this? So XL will be what? XL will be X new, the new root. And what is FXL? What is FXL? You have changed the root to be X new. So what is FXL? This one will be the FXL, no? Now, yes or no? Here, students, please wake up. Good morning. Please wake up. It's very okay. So this will also be fx new. Okay, because in the formula you have to use fx. You are using f of x in the formula. Okay, in the formula you are using f of x. Now, how will this change? If you are not going to make a change to fxu and fxl, then the same value will be running, no, again and again. Okay, so the same value will be running. But as per the rule of your Regula falsi, the f of x also is involved in the formula. So you have to change your f of x value also. So this is in case of negative and this is in case of positive. Now you find the new root. Okay, so this is your x new. You will also find f of x new. When you find f of x new, you are finding this to be positive. So now the root lies between this and this. So this is your positive, this is your negative. So the XL and FXL is not changing. It is not changing. Now here it is changing. XU is X new and FXU is FX new. Okay, so the logic as per bisection, only your formula is changing. The logic is as per bisection, only the formula is changing. Are you understanding that, students? Everybody? Hello?
Yes, ma'am.
Okay. So we go for this. We go for writing it exactly how you saw here. Okay, we'll write it exactly how you saw here. So we go for finding fx new. So for that you have to assign x is equal to x new because your equation is in terms of x. So evaluate f underscore expr. Okay. F underscore. So we got x new, fx new also we have, x new also we have. We have both here. Okay, so this is there with us. So now we go for finding. So if, what is the condition I have to give? Can someone tell me? What is this negative and positive? What do you have to check here? If, see, you must tell me this. If, no. What is positive, negative here? What is positive, negative here? XL or I mean the root or the f of x value? F of x value. So what is the f of x value? The new f of x value. What is the new f of x value?
F new.
X new. So fx new is 1 second. I'm coming. So if fx new, if this fx new is negative or positive, you will decide the new root. Okay, new range. You will decide the new range. Now let us take one condition, less than 0. If it is negative, that is how our example also works. Okay, so you see the PowerPoint presentation also. So if it is negative, what is that I have to write? This one I have to write. This part I have to write. Is it not? So I'll be writing that now. Yes or no? XL is equal to X new. FXL equal to FX new. And if it is positive, what should I write? If it is positive, you see here, if it is positive, this has to be written. So I'm going to write that XU is equal to X new and FXU is equal to FX. Oh, that is all. Okay, so hope it's clear, students. This will get repeated how many ever times you want, you can repeat. Now you want to see the intermediate roots. Suppose you want to see the intermediate roots. You can give a printf statement here. Printf intermediate roots equal percentage f comma new. You can give backslash n. So you can give a backslash n here also. You can give a backslash n here also so that it is seen beautifully. That's all. Okay, is this clear, students? So the root, the final root will be whatever is the newest root that will be there. Is it clear, students? Everybody? Did you all understand?
Yes, ma'am.
Yes. So okay, so I'm saving and running. So there is no error. What is the name I had given? RF. So RF of, let us go for the same equation, x cubed minus 4 into x minus 9, comma 1 comma 2 should give me wrong interval. It's giving me wrong interval because it is negative and negative. So if I give 2 comma 3, then it is giving me the intermediate. Now if you notice, see these values, it is repeated from here, same values. Okay, to avoid this only we usually add a condition here, but I am not teaching in that manner. So you just reduce the, you can reduce it to 7. So let us run it again. So I've run this again. Let me clear the screen. So run it again and I go for this. So I have arrived at the root here. Okay, so This we saw this getting repeated after this it's getting repeated. So you can try 10 over here, you can try 15 over here, and then you can go for. Or if you don't want all that, you will find the difference between the previous route and the current route, and if it is less than 0.0001, then you say you have arrived at the route. You can add a condition, that is also fine, no problem. So that condition I'm not teaching you now. You can go for handling it using iterations. So that is easy for us. That is not an issue at all. So you can handle it with iteration. Is this clear, everybody? Did you all understand?
Right.
Yes, ma'am.
So now what are you going to do? You are going to take a screenshot. You please don't add this in your code. Not necessary. Okay, it's for you to understand, that's all. For the other batch, they were adding this also in the code. Please don't add this in your code. This is for you to understand, okay? Have you taken the screenshot of this part? Shall I scroll down?
Yes, ma'am.
Everybody?
Yes, ma'am.
Yeah, now
Yes.
you please take this. Yeah. Take this also, screenshot of this also. You please try with the equation sir has given in the lecture to see whether your code is correct or not. Okay, please do that. Any random equation which sir has solved in the lecture, please give it here and see if you're getting the correct route. Because you would have done not for more than 4 iterations. So you can give for I is equal to 1 to 4 and you just match your solved example and this answer. That's all. It should be the same. Okay, shall I proceed? Have you taken the screenshot? Everybody? Hello? Done? Okay, shall I put, I'm proceeding to the next. We'll do 2 programs here, or if you don't mind, I will do all the 3. Okay. If you allow me, because I don't want to just go on teaching and just leave it off. Okay, so let me do save as. Save as, and I say secant. Okay. So again here also you are not going to change. I mean only the formula changes. So I say secant. Okay, so this is all done. Now secant, I'm going to use the same formula. I'll be using the same formula, but the new value varies over here. It is not like this. Okay, it is not like this. This is not the way it goes for secant. Okay, this is another way how it goes for secant. Wait, I'll tell you. Or you will tell me. Why should I tell you? You will tell me how it goes. So we'll be using the same formula. So there is no change in the formula. But here there is a change. I'm going to delete this. Here there is a change. Okay, the formula is not changing. It is the same. Or if you want, have you done in terms of x0, x1? The formula, students? Your formula is in terms of x0, x1? Hello?
Yes, ma'am.
So we can change it in terms of x0, x1 also. No problem. Okay, so you will have, I'm changing, please watch closely. I'm changing this to x0, x1. So this is your x0. So this is your x0. This is your x1. This is your, sorry. This is your fx1. This is x1. This is x0. Fine, done. So I've changed it in terms of x0 and x1. So now here it will be x0, sorry, it will be x1. and this will be x0, this will be x0, this will be x1, this will be x1, this will be x0. So how are we going to write it? So I'll just copy paste this. X lower is 0, x upper is 1, upper is 1. This is going to be x0, this is x0, this is going to be. Okay, so I'll just copy paste this. Control and control. Okay, so I'm sure this you have studied as x2, right? This you have studied as x2, students? Hello, in your lecture.
Yes, ma'am.
The new root is x2. Okay, so here, let me put it in terms of how. Now you may find, now when you search in Google, suppose you go for finding the formula. I mean, yeah, I'm sure you apply the same formula. Secant method formula, suppose you find, maybe you would have used this formula. You would have used this formula. Yes? Tell me, students.
Yes, ma'am. We are like,
Yeah, you have applied this formula. So when we solve this, actually, the code is the short form of it. When we substitute the new root in this, it's almost it is the same. It is this form. This is what we are doing. When you simplify this, you get a formula same as what you are seeing. I have not changed the formula at all. It is the same as your regular falsi, but how will this x0, x0 and x1 change? That logic is different in secant. Okay, the formula, there is no change in the formula. But how will you take x0, the next x0 and x1? That is different in secant. That's all. The same thing happened in regular falsi also. Okay, in regular falsi, you had the f of x was there in the formula. So you found the f of x of the new root that you got. Okay, that's all. That was the only change when compared to bisection, and the formula was different. Now, when you compare regular falsi and secant, how do you decide the new two roots? Okay, this x0 and x1. Next iteration, what will be x0 and what will be x1? Only there is a change. Okay, only there is a change. So what is the change? Can someone tell me what is x0 and what is x1? Can tell me, because you need that in the formula. Next iteration, you need x0. Here we have x0 and x1. It was already given to us. Now here in secant method, when you come the next round, the next iteration, I need an x0 and x1. What is x0 and what is x1? Can someone tell me?
Ma'am, x0 is x1 and x1 is x2.
Yes, x1 is x2. That's all. It is as simple as that. The latest two roots, you have to remember like that. Or the previous two roots, the current root and the previous root. That is the latest two roots. That will be substituted in the formula. Okay. So the one that you found as a new root will be x1. The one that was here, the second root, okay, that will be your x0. This will continue, but we have to find f of fx0 also and fx1 also, because this has changed. So you have to find the new fx1 and fx0 and fx1 also. So for that, what you're going to do is, now the equation is in terms of x, so you have to write this, and now your fx0 is estr of f underscore extr. Okay. Now x1 is x2. So x is equal to x1 and fx1 is equal to evstr of f underscore extr. You have to find the new fx1 and fx0, is it not? So you have to do this, because why you are storing this in x, you all know, because your equation is in terms of x. And then you find fx0. The same way, x1 is equal to x2, you store it in x and then you find fx1. That's all. Nothing, no other. Now, how will you stop? If you want, you can check if fx0 is equal to fx1, you can print the root. Here it is an easy condition. If fx0 is equal to fx1, if both are same. I'm just teaching you how you can add a condition. Okay, so suppose this is there, then you can add this here. Control X, Control V, X2. That is your new root. Okay, using Secant method. So you can do it this way also. I'm just in the beginning, I'm adding 10. Okay. We can see where we can stop. It will stop automatically. Okay. So did you all understand, students? Any doubts in this? This is same as your the others. Any doubts in this? We need again fx1 and fx0. So x0 is x1 and x1 is x2. These two are the two steps, new two steps. So we have to find fx0 in terms of the new root x0. Also, we have to find fx1 in terms of the new x1 value. So we are finding fx0 and fx1, and then we are checking whether, if you see fx0, and because fx0 and fx1 has the latest two roots. So if those two are equal, because you remember in the regular falsi, we saw the roots being equal. So we stop when it is equal. So when it is equal, we declare that whatever was the new root that was found, that is going to be your the actual root. Okay. So this printf will be executed only if fx0 is equal to fx1. Okay, only if fx0 is equal to fx1. Or you can give x0 is equal to x1. Whatever condition you want, you can give. Okay. You can give x0 is equal to x1 also. If the roots are equal, you stop. That is also fine. Or fx0 is equal to fx1 also, you stop. That is also fine. Okay, so you can do it that way. No problem. So whatever, you can try all the ways you want to. It should execute, but that's all. If it is executing fine, no problem. Let us try. Okay, so now what is the name I've given? Secant of x cube. Is it clear, students? Hello, please let me know. I will explain. Not clear, I will explain any number of times, but please stop me then and there. So see here, you saw that here when it was calculating, the condition was not, it is not correctly checked. You see here we had given 1 is to 10. Is this going for 10 iterations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is going for 10 iterations and it is printing root is equal to. So we can say if x0 is equal to x1. We have not aborted. Yeah, that is it. No, I will add both and I will tell you. You have to abort. So then it will stop. Okay, so that was the issue. So I go for calling this. Oh, even then it is going 6, 7, 8, 9, 10. If I go x0 and x1, why it is not getting aborted? Okay. No problem. You please don't get confused. Okay, no problem. No problem. So here, what we have, so hope you followed this part, students. This part, everybody. Hello,
Yes, ma'am.
everyone.
Yes, ma'am.
I'll just print this out. Please don't get confused with what I did. Just forget about that. So here, anybody who did not understand, please let me know. I will tell you how it is done. Okay, so you go for printing the root outside as we did in all the other methods. Okay, just print the root outside. That's it, finished. Okay, so you can take a screenshot of this. Have you taken?
Yes, ma'am. Done.
Yes, ma'am.
Scroll down. Take a screenshot of this. Okay.
Yeah, ma'am. Okay.
Now I think I'll teach Newton-Raphson also, because then you can work with all the three. Okay, I'll finish teaching Newton-Raphson also. Then you can work with all the three. Now Newton-Raphson, let me remove all this. I'll type it out again. Okay. Let me remove all this. Now this also I will remove. If there is an error, we'll see. So here we are going to learn a new way of defining a function. Of course, for some of them I have already, someone had an issue with the Scilab cloud. So I mentioned this that time. I think in the last lecture or before that. So here we are going to use a new way of defining a function. Of course, when you know this, you will not go for the way we studied for bisection, um, Regula, falsi, and secant. Okay, but this is an easy way. But here we are forced to use this because in your formula, you all know the formula. What is the formula? Can someone tell me? What is the new root? X1 is equal to
X0 minus f of x0 upon f dash of x0.
yes, x0 minus f of x0 by f dash of x0. Okay, so that is your formula. Now, in this Newton-Raphson, it is different from the three methods we saw. In bisection, in Regula, falsi, and secant, we assumed the range of the root. We had two values. That is, the root is between 2 and 3. That is what we decided. Is it not? But in Newton-Raphson, we go only with one root, either 2 or 3. Yes or no, students? Hello. We go with either 2 or 3. Can we go with a range 2 and 3? I want an answer. You cannot forget things after you finish your lecture, please. I want an answer. So for example, for the example that we are discussing, 4x minus 9, we know that the root lies between 2 and 3. And I think for 2 it was minus 9, and for 3 it was 6. Am I correct? This was for x, and this is f of x. Okay, so this is what we got actually. Am I correct? Hello, do you remember? That's how we got it as 2 and 3. Yes or no? Hello. Yes. And I always told you how to check your answer. I mean, I told you the first lecture and also the second lecture, I think. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. So here is your root. 0. If you're getting f of, this is f of x. I have, in the form of a line, I have given the values of f of x. So here the x value is 2. Here the x value is 3. And here is your root. Because it is not in the center, you know it will be beyond, your root will be beyond 2.5. And you know the root is 2.7 something. We have done it using bisection method, regular falsi method, and secant method. So it's very clear it is nearer to 3. Okay. So I told you this is how you will cross check whether you are on the right track. Now in Newton-Raphson method, you have to assume the first root x0 as either 2 or 3. Now, how do I choose whether it is 2 or 3? Can someone tell me?
Then there is a condition.
Huh?
That is the condition.
There is a condition. Okay, that's what is taught in theory, right?
Yes, ma'am. Mod of f of x into f double dash of x
No,
could be.
I'm not interested in that formula because my teacher taught me an easy way. Okay, so here, you know where 0 is. 0 is closer to 3 or 0 is closer to 2. Tell me that first. 0 is closer to 3 or closer to 2.
Closer to 2.
Okay. Or 0 is closer to 6 or closer to -9. It is closer to 6. So the first assumption is 3. An easy way to assume the first root in Newton-Raphson. Is it clear, students, everybody? Hello? Did you all understand? An easy way to assume. Okay. Theory, please do follow what sir has said, whatever formula sir has given. Please do go with that. Okay. Now here, in the practical section.
Can you repeat that formula?
Formula, I didn't say any formula. I didn't say any formula.
Ma'am, that closest one.
See, 0. This 0 is closer to 6 or closer to -9?
6.
6. What is the corresponding x value? 3.
3.
So your x0 is 3. Is it clear?
Okay.
Okay, so this is one easy way to, which of course my teachers taught. So this is one way for Newton-Raphson method, because of course in the theory exam, suppose you're asked to solve, please solve it as sir has taught you. Okay, but you have some easy methods, whichever I know I will share with you. Okay, I may not know easy methods for all the methods that we are going to discuss. The things that I know I will share with you. Okay, so here this is the easiest way to assume the first root. Okay, so x0 is equal to 3. So here you can easily decide whatever. Now in case, suppose you have got f of x as -2, -1, 0, 1, 2. Suppose your f of x value is -2 and 2. Okay, so maybe when your x is equal to 2, you're getting -2, and x is equal to 3, you are getting 2. Then you can go for either 2 or 3 as x0. Okay, where you cannot choose. Both are equal distance, then no problem. You will go for either 2 or 3. Okay, so it will be exactly in the center. Your root will be 2.5. Okay, in that case. So that there it is not an issue. You can go for choosing anyone. But if you see a very legible distance, it's not subtle. Okay, you have a very legible distance. then you can easily go for choosing the new value x0. Is it clear to you, students, everybody? Shall I proceed?
Yes, ma'am.
Okay, so now we go for defining the function, and this is how you will define. First, you have to give the first value y is equal to f of x. You have to give in quotes. Okay, so you're going to go for giving the equation for the first, not f dash of x, this is f of x you're going to give. What is the equation you have to give? Y is equal to, let us go for the same equation. I will go for the same equation. You all please go for all the equations that you have, please try. Okay, you give it like this. Now here you need the second, you need f dash of x also. So you say, now you have used y already, so you say y1 is equal to f. You cannot give f dash and all. Okay, it should be a variable name only. You cannot go for giving f dash and all. That is all not identifiable. And y1 is equal to, go for the derivative of this. What is the derivative? 3 into x. Yes, students? Am I correct? Am I correct? Yes. So we go for the derivative of this equation. So 3x squared minus 4. Okay, derivative of constant is 0. So you don't go for that. The initial root x0 is equal to 3 because it is closer to 0 is closer to 6 and 6 is because of the x value 3. So x0 is equal to 3. Your loop starts. This is the easiest one. Huh? 1 is 2. You can go for any number. And the formula directly, x1 is equal to x0 minus f of x divided by f1 of x. Okay, whatever variable you have used here. Now, it should be x0 minus the whole term. So, a bracket is necessary over here. Okay, so sorry, it is not f of x, it is f of x0. Okay, x0 minus f of x. 1 second. So since we have used x0, we are going to go for f of x0. Okay, and now the new root. Now I should come back here. So this should go on repeating. So your x0 is now the new root. Okay, that's all. It is only this much. Huh? You don't have anything else. It's as simple as that. So you go for printing the root using Newton Raphson. F1. You want to see the intermediate roots? Please go for seeing the intermediate roots. F, printf, backslash, intermediate roots. Okay, so you want to see the intermediate roots. Hope it's clear, students, this one? It's as simple as that. Do I have to explain this again? Did we do anything? Nothing. We just wrote the formula exactly. Now, when I come for the next round, this x0 will be the one that I found before. And that is there in x1. So I say x0 is equal to x1. Is it clear, everyone? Hello?
Yes, ma'am, it's clear.
Others in the meeting?
Yes,
So I
ma'am.
go for running. Let me go for PLC. So I go for running and I see, you see the roots are getting repeated. You see here it is even more, you're getting it in the third iteration itself. Let me go for 5, okay? So you see the approximity as you go for the methods, okay? So you can see the number of iterations that are being taken in bisection. I have used the same equation. In bisection, when did we arrive at the root? In regular falsi, when did we arrive at the root? In secant method, when did we arrive at the root? In Newton-Raphson, when did we arrive at the root? So you saw the difference. So you see here, it is arriving. You are getting the root in the third iteration itself. Okay, so you see, as you go on with the methods, you have many more methods. Okay, so we are discussing only these 4. So you can see it is even more, the root is even more approximate as you go for the different methods. Okay, so the number of iterations that are necessary are less as you go for different methods. Newton-Raphson, it is very much less. Okay, is it clear, students, everybody? Yes?
Yes.
Yeah.
Yes, ma'am.
Do take a screenshot of this. Done. Have you taken?
Done, ma'am.
Now the time is 8:40. Now, because regular falsi and secant method are almost the same. Even Newton-Raphson is just 4 lines. All the 3, how much time maximum you need? Or you will finish one by one, and I want to see what is it. You tell me, accordingly I will ask you to.
Ma'am, one by one.
Yeah, I'll ask you to present. Majority, please. Yeah, what did someone said something, I think. Ashtalakshmi, what
Ma'am,
did you
one
say?
one by one.
You're using Scilab Cloud, no? You do. Yeah, what about others?
Ma'am, all together?
You, sweetie, you are very fast in doing things. I want others to say. Others, please give me an idea. You can go for 1 or you can go for 2. You can go for all the 3. But I want you to complete. And the assignment, now I can give the assignment. Okay. So shall I give tomorrow night as the deadline for submitting the assignment? Practical 2. Tomorrow night. Okay. Now, but I want to see it now. Now it is 8:40. 9:40. 1 hour I'll give you. And I want to see something. Can I go for the 2, or those who are completing 3? It is okay. But can I expect you to complete at least 2 in 1 hour? Hello?
Okay, ma'am.
Everybody, others in the meeting.
Yes, ma'am.
34 of you.
Okay, ma'am.
Okay? It's okay. I will ask you to share at 9:30. So whatever you have finished, you show me. Okay? I think that would be better. 9:30, I will 9:30, not 9:40. 9:30, I will ask you to share your screen. And I should, whatever you have finished, you will show me. That is enough. Okay? Okay, students? Is it fine?
Okay, ma'am.
Okay, fine. No problem. Please do it sincerely. I will ask randomly, I will ask someone to share the screen. I don't want any reasons. I don't want any reasons, please.
Now I am declaring another variable.
Can you see the assignment? Tomorrow night I have given the deadline. Okay, students? Have you all finished?
Yes, ma'am.
All the three, sweetie?
Yes, ma'am, all the three.
Share your screen. Your name starts with Nadar.
Yes, ma'am, Nadar Michael Sweet.
Nadar. Yes, present. Yeah. All the three, carefully. Yes, sweetie present. After that, carefully present. Yes, how many of you have finished all the three? How many? Just raise your hand. Very good. How many of? Okay.
Ma'am, can you see?
Yeah, I can see. But not that clear. Huh? There is some issue. I don't know whether it is my issue or your issue. It's blurred. It's okay. It's okay. Hope you have not changed the code. That's all. That's what I want.
Ma'am, can I show the next one?
Now I am able to see. Okay. Hope you got. See, please try for some other equation also, students. You are always showing me with what I have given you. That I have already demonstrated. No.
Okay,
You please
ma'am.
demonstrate it with some other equation, everybody. Because this one I have already done it. No. So surely it will work for you also.
Okay, then I will do it with others.
That is okay. That you do later. Show me the others also. Okay, now all those have raised your hand, just lower. How many of you have finished with two programs? All those have raised your hand. Please lower your hand. How many of you have finished with two programs? Acha. Bhuvanagiri has, Supreet has finished with two programs. So all the others have not finished anything, right? Out of 30 of you, I think around 12, 13 of them have done something. Others have not done anything, right? Fine. Which is this one. This one is secant. Show me secant, sweetie. X0 is equal to x1, x is equal to x0, x1 is equal to x2, x is equal to x1, fx1. Okay, fine. The same equation, na? Newton-Raphson code. No, show me the code. X0 minus x0 is equal to x1. Okay, fine. Done. Atha, share your screen. Sorry, carefully share your screen. Now, please, all those have finished the 3 programs, raise your hand. Let me see. All those have finished all the 3 programs. Please raise your hand. Yeah. Remove that selection, no? Carefully remove the selection, please. Come down. I want to see the for loop. FXU x is equal to x new fx new less than 0. See, I always prefer you to write in a structured manner, please. Everything you don't start in the first column. For loop. See, you have seen how I write, no? I actually teach that when I'm teaching imperative programming. I always need, if there are statements belonging to the true part of the if, it should be inside if. If it is belonging to the false part of if condition, it should be inside else. Please do not show me the code like this. I don't start everything in the first column. Statements which are within the for loop should be inside the for loop. You cannot write if just below. You cannot write for as carefully as done. X new will not be just below the f of for. You must put it inside. And you know something in Python, this only speaks just because you're typing it inside. That means those statements are within for. There is no open bracket, close bracket. It is exactly like Scilab. But in Scilab, it considers this. But in Python, it will not consider this. It has to be typed inside by default. In Python, only indent speaks that it is this statement is within for or this statement is within if. Please have the habit of doing it in that manner. Everybody. It's not only you. I've seen many others also doing this. I don't like to see the program like this. How do I know what is inside what? Of course, I know by seeing each line, but this is not the way you should present. Let me just tell you. Yeah. Excel, XU, FXU. Okay, fine. Fine. Next program. X2, X0, X1, X is equal to X0, Fx0. X1 is equal to X2, X is equal to X1, Fx1. Okay, come down. Okay, fine. Hope it's working. Yeah. Yeah. Newton Raphson. See, the others who have never shown to me, I want to see their work. Hema Gounder, have you shown me? Sahiti, I think you have shown last time. Siddesh also showed me last time. Viola also showed me last time. Dinesh Kumar, Jay Kumar, did you show me till date any work? Prabhakar Devendra, have you shown me any work till date? Shweta Bandari, have you shown me any work till date? Yeah. Newton Raphson, please reduce. See everyone, please reduce the iterations when you see that the root is arrived. Please reduce the iterations carefully. What? Okay. Fine. No problem. So there the number of iterations was more. That's what you're trying to say, no? Mm.
Ma'am,
Yes.
even I tried with other equation. It's working.
Shubha Panraj, share your screen.
Hello, ma'am. I'm attending lectures in mobile. So, can I turn on my camera and show the screen?
Show me one program.
Okay. Ma'am, it's visible
Little more.
now?
No, go closer. This is your regular falsi, no?
Yes, ma'am.
Come down. Little down. Okay, fine. It's working, no?
Yes, ma'am.
Enough. Don't show the others. Hope others are also working. Means I'm not comfortable seeing like that. That's why.
Yeah, ma'am.
Ajinkya Gadge. I'm making you the presenter. Please present. Ajinkya Gadge.
And is it visible?
Yeah.
First position method.
Come down. For loop. Next new. Okay, fine. Next program.
Secant method.
Okay. Next program.
Newton Raphson.
X1 of X0. Okay, fine.
And this is the output.
Yes. Fine. See, students, I'm sharing my screen. 1 second, please wait. Hope you can see my screen. So please take a screenshot of this. Please take a screenshot of this part. This is what you will paste now. You will do now. Okay? Your questions. Have you taken a screenshot of this? Done? Okay. Now what you will do in this, the sample I have pasted already in Teams, I think. So you know how to name the file NSM practical 2. Batch 1, your batch 1, then batch 1, your roll number. This is the name you will give. You'll write the roll number, your name, and practical number 2 you will write, and you will paste the question. You will type the question here. Then you will type each program, the question of each one you will write here, and you will paste the code in Scilab, then the output screenshot. Okay, the same thing will follow. 1 second. Hello. हाँ बोलो कि बोलो हाँ
ನಮ್ದು ಫೋನ್ ಸರಿಯಾಗಿ
So you have to follow this same pattern, and you just change the number of the practical, and you will type the questions and you will paste the code. Okay, students? Hello? Hello?
Okay, ma'am.
Yeah. Please paste the formula also. However, I have told you to do the practical number 1 the same way you will do practical number 2 also. Is it clear?
Okay, ma'am.
And I have assigned the assignment for tomorrow night. Okay, fine. What is journal now? What is that what are you asking carefully? Huh? You have to louder. You have to no, what you're loading here is final assignment. This is your journal. This is your journal. From this year, we have started this. Okay, this is your journal. As you upload, finished. Okay, so for me, it is easy to see. Now, for example, I have assigned NSM practical 1. Okay, so I will see here. I can easily see how many of you have not see these people have not turned in. There are so many people who have just viewed and not turned in. So I can easily know how many of you have turned in, how many of you have not turned in. Is it clear? Everyone? Okay, so this is how I will see whether you have turned in or not. So this is easy for us to, to keep track how many of you have done, how many of you have not done. Okay. That is not an issue. No, it should not be difficult for you because as you finish, you will make the journal. No, it was there previously like that. As you finish, you have to make the journal. So then it will not be difficult for you. No, understood? You should have made the journal, made the file as you finish. So then it would not have been difficult. Okay. Yes, Mir, Nabil Mir, can you present? Nabil Mir.
Yes, ma'am. Hello, ma'am.
Yeah.
Can you see the code?
Yes, okay. Next.
This is the secant one.
This is secant, yes. What about regular falsi?
Yeah, regular falsi is here.
Okay, fine. Next. Newton Raphson.
Newton Raphson.
X0 is equal to, therefore I is equal to. Please increase the font while sharing your screen, everybody. Fine. Please, you remember what I said when Kaifali showed me like this? Please follow that hereafter, everybody.
Okay, ma'am. Okay, ma'am. Can I unshare?
Next. Drishti Hegde. Please share your screen. Drishti Hegde.
Yes, ma'am. Ma'am, is it visible?
x1 is equal to x0 minus x0 is equal to x1. Okay, fine. Next code. This is secant. X0 is equal to x of x1. X1 is equal to x2 is equal to x1. Okay, fine. Regular falsi. X is equal to x nu. Fx nu less than 0. Xn xl fxl xu fxu. Okay, fine. Mm, Mahalakshmi. Mahalakshmi. Mahalakshmi Kona.
Yes, ma'am. Yes, ma'am.
One second, I'm coming. 1 second. Yes, Mahalakshmi. Share your screen.
Can you see, ma'am?
Yeah. Come down. Show the for loop. Ah. Fine. Next. X0 is equal to x1, x0. Okay. Fine. Show the for loop always, please.
Okay, ma'am.
Ah. X is equal to x0, x1 is equal to x2, x. Okay, fine. Next. That's it. Okay, fine. Fine. Yes.
Okay.
Yeah. So students, I hope others also have done it exactly like this, okay? And hope it's working also correctly. Yes, students, hope it's working correctly. Hope you all watched how others have done and hope you have also done in the same manner. Yes? Okay. And who did not share, whom I did not allow to share your screen. Fine, students. Thank you for today. Now, when you come for the next practicals, please take care to prepare or to remember. I mean, you just go through Newton forward interpolation. I'll only teach Newton forward. If once I teach forward, it is easy for you to understand backward. So I will take the whole time to explain what is Newton forward. Okay, the whole the 2.5 hours that we have, I will try to explain what is Newton forward. I mean the coding part. Of course, I'll have to show an example and I have to show you how the coding works, how to code it. So please understand what is Newton forward and income. Hope it is over in the lecture. Newton forward, backward, Lagrange's interpolation. Yes or no? Hello?
Yes.
Newton forward is over in the lecture.
Ma'am,
No, ma'am.
No. What are you saying?
नहीं मैम नहीं हुआ है मतलब नाम नहीं सुना अभी तक मतलब न्यूटन फॉरवर्ड मैम अभी तक लेक्चर में नाम नहीं सुना है न्यूटन फॉरवर्ड
क्या बात करते हो? अయ్యో. What chapter is that? Then I also have to shift like that, no? There is no use of me, unless and until for your case, it is over in theory, I cannot go forward. Okay. So that is why I'm asking, what is there? Gauss-Jordan is going on? Gauss-Jordan?
Like shift operator, E-shift. Shift operator.
Shift operator? Na, Baba. Shift operator what?
Ma'am, we are talking about interpolation chapter.
So auto. Wait. You have chutta. 20 rupees. 1 second, students. Interpolation is going on, is it?
Yes, ma'am.
So then it will be done. Don't worry. It will be done.
मैम शायद ये वीक में होगा मैम अभी मतलब
It will be done. It will be done. So please remember Newton forward interpolation. It is very much necessary. Okay, fine. Thank you, students. You can leave the meeting.
Thank you, ma'am.
Thank you, ma'am.
Yeah, I'm ending the meeting. Okay.